So we've talked about ionic bonds in the past. This is another type of bond, and this one's called the covalent bond. Remember how valence means like that outer shell, valence electrons, and co usually means sharing. So covalent means that two things are going to share those covalence bonds, and so it's going to be an equal sharing. It's a pretty strong bond. So if you look here, we have chloride and another chloride. And if you remember, chloride has 1, 2, 3, 4, 5, 6, 7 electrons. And this guy, of course, has 7 electrons in its outer orbit as well. So granted, this is just the outer orbit. If we counted all the electrons, it would have much, much more. It would have 2 plus 8, that's 10. It'd have 17 total. But really, we're only interested in its outer orbit because that's that valence shells, and those are the ones that are the most active. So chloride, the two chlorides each have 7 electrons in its outer shell. They each want to have 1 extra. Remember how they want to get to the octet rule, fulfill it? So what you're seeing on the right is that they both come together, and what they're going to do is share 1 electron. So sometimes this guy has 8 electrons in its outer orbit, and sometimes this has 8 electrons in its outer orbit. So basically what happens through this process is that they both fulfill the octet rule. They both are happy because this one has 8, and then once in a while this one has 8. And this happens in milliseconds. And because it happens so quickly, they both feel like they're sharing this bond. And the more electrons they share, the stronger the bond. So this is a very strong bond. Again, this is the covalent bonds, and it's just that these guys come together to share 1 electron. If you look below here, this is another representation of how to write different types of reactions. So we're looking at chlorine and chlorine. At first, we were looking at only the valence electrons, because the other ones, they fulfill the octet rule. Like here, this has 8 electrons, octet rule is complete. Here it only has 2 electrons, but remember the first shell doesn't do the octet rule, it does that thing called duet rule. So only 2 electrons in its first shell, up to 8, up to 8. So 2, so he's completely filled. Here it's got 8, completely filled. Here's the trouble one. It's got 7, and this one has 7. So another way to depict that is just by looking at the valence electrons. So if you look at chloride, 1, 2, 3, 4, 5, 6, and then they put usually another dot over here, that would be 7. Here, same thing, 7, 6, but because they usually put another dot over here, what happens is, because they're sharing that electron, we put a dash. And that dash means that sometimes this electron's over here, sometimes this electron's over here. So we give it a dash, and that's a bond. So that tells us how strong this bond is. Again, this is not something scary, it's really something pretty easy. These dots represent the valence electrons. We're missing 1 dot because remember how we're supposed to have 7? And we made that as a dash because sometimes this guy has 1 of those electrons, sometimes this has 1 of those electrons, but it shows that these guys are bonded, and it shows that they're fulfilling their octet rule, even though sometimes this one has it, and then sometimes this one has it. It's almost like temporary custody of that electron, but because of that, they have a strong bond. We could make it stronger. So for instance, if we look, and I keep looking at chloride, but please know that other molecules do these reactions. It's just easier to think of one thing versus learning another one and another one. So for instance here we have H, hydrogen gas. If you go back to the periodic table, you'll see that it has 1 electron. So what happens is they go ahead and share. So they're doing that covalent bond. So 1 hydrogen comes with another hydrogen. That's why it's called H2. And it's a single hydrogen bond. It's a strong one, so sometimes he has 2 electrons, sometimes he has 2. And keep in mind, the first shell, it wants to occupy the duet rule. After that, everything wants to do the octet rule, at least for biology. With O2, what ends up happening is the first shell has 2 electrons, super happy. The next one has 1, 2, 3, 4, 5, 6. And what ends up happening with oxygen is that it wants to go ahead and have all of its electrons fulfilled. And let me go back and show you what oxygen looks like on that periodic table that I've set up for you. So if we look at oxygen, we'll see that in its outer shell it's got 1, 2, 3, 4, 5, 6 electrons in its outer orbit. So if we go back, this one's got 6 electrons in its outer orbit, this one's got 6 electrons in its outer orbit. So remember how it wants to get to 8, which means it wants to pick up 2 electrons? So what this happens in this situation is that they're going to share 2 electrons to kind of keep that covalent bond going. So sharing 1 electron is great, but sharing 2 electrons make you a much stronger bond. And that's why you see a double dash here. The double dash just indicates that they're sharing more electrons. So this one's sharing 2, this one's sharing 2, so a total of 4 electrons are being sort of shared. If we go and look at the triple bond, what you're going to see is that instead of having, just a couple electrons being shared, they're going to share 3 electrons total. So this one's going to have 3 to share, this one's going to have 3 to share, and that's going to give us 6 shared electrons, and that triple bond is the strongest one. And that's really it. We can't share 4 electrons. There's no such thing. There's no such thing as 4 bonds. So this would be the strongest of the covalent bonds. This would be the weakest of the covalent bonds. But because they are sharing electrons, it's actually a very strong bond. There's 2 types of covalent bonds. There's polar and there's nonpolar. And if you think about poles, you kind of think about the equator. So polar means usually a charge, nonpolar means no charge. So if it's polar covalent, that means it's an unequal sharing. So sometimes one of them is going to get a lot more custody of the electron and the other one won't. Nonpolar means that they're equally going to share 50-50% custody of that electron. And that's going to tell us which one's going to be slightly positive, which one's slightly going to be negative. So here, if you look at chloride again, sodium chloride, they're going to share that electron, and then what's going to happen is the Na is going to get it once in a blue moon, but it's just another way of looking at who gets most. So here's nonpolar. This was probably an easy way to think about it. So you could see that with chloride, how many valence electrons do we have? Or another way of saying it is, how many electrons do we have in its outer orbit? 1, 2, 3, 4, 5, 6, 7. Same thing over here, 7. So when they come together and they share, this one's going to have equal custody and this one has equal custody because they both have the same strength. And that's why we put the 6 dots on the outside with the dash. This one's nonpolar. With a polar one, this is going to be something like water, where this hydrogen has 1 electron. This hydrogen has 1 electron. Where this oxygen has how many valence electrons, or how many electrons in its outer orbit? 1, 2, 3, 4, 5, 6. So what will happen is this hydrogen will come together and say, hey, let's share. This hydrogen will come over here and say, hey, let's share, but the oxygen is actually the strongest molecule. How do we know it's the strongest molecule? Well, we know this because this guy only needs 2 more electrons to fill its outer orbit, and it's got the most electrons and the most positive charges, so he's going to be the one that's going to basically hold those electrons the most. So what happens in this situation is we get 1 bond, covalent bond from here to here. We get 1 covalent bond from here to here, and this guy is going to have the majority of custody of those electrons, and every once in a while these guys are going to get the electrons for a small amount of time. And that's called the unequal sharing, or polar. So when they do come together, this is just a water molecule, we'll find out that one area of the water, the oxygen, is slightly negative. It's slightly negative because it's got 2 extra electrons. The hydrogens are slightly positive because they've got no electrons, so they've got just 1 proton but no electron. So this is going to make it slightly positive, this is going to be slightly negative, and this gives water some unique properties that we'll talk about in a few minutes. One more thing. You can have a polar covalent bond and a non-covalent bond, and they sort of cancel each other out. This is something that they're going to really talk about maybe more in chemistry, but for us, when we think about polar and non-polar, we're going to just think about how these charges come together. I just wanted to mention it because your book talks about it a little bit, and chemistry professors talk about it a little bit. So I just wanted to just mention it, just so you knew it. And when I think about these types of bonds, I think about equal and unequal sharing. So here you can see 2 equally strength polar bears. They're going to share that ice cream equally. One can't have more of it than the other. They're both about the same size. Whereas if you look at this polar bear versus this penguin, the penguin's going to get maybe a couple licks of that ice cream, and this guy is going to get pretty much the majority of it. So this would be an example of a polar bond, pardon the pun. This one's going to be a non-polar bond because they're going to equally share it. This guy, again, same thing. Polar because it's got 2 things that are much stronger. They're going to take the ice cream. He's going to get basically very little. And this is the exact thing that water is going to be like. Imagine these penguins are hydrogen. This is oxygen. The polar bear is going to get the majority of the ice cream. These guys are just going to get a lick here or there. So just as a quick recap, covalent bonds, they're going to be the strongest bond that we're going to talk about. They share the valence electrons. They're the strongest bond. They could be polar or non-polar, but keep in mind, co means that they're equal. Valence is the valence shell that they're going to share, so they're equally going to share those electrons. The ionic bonds, which we talked about before, is where one will just take the electron and the other one will give it away, and through that process, one becomes positive, one becomes negative. And here's a little cartoon to sort of recap that whole process. This guy gave the electron or the ice cream away, so he's going to have all of it, he's going to have none. Polar covalent, he's going to have a little bit of the ice cream, he's going to have a ton of it. And then non-polar covalent, they're both equal in strength, so they're both going to get equal amounts of ice cream.